Hello and welcome. In this video, we are introducing the TCP IP model, the fundamental framework that powers the internet and modern communication systems. The TCP IP model is a set of rules that allows computers to communicate over networks, including the internet. It organizes how data should be transmitted, ensuring that it reaches the right destination efficiently. Unlike the OSA model's seven layers, the TCP IP model simplifies communication into four layers. The TCP IP protocol suite was developed by the United States of Department of Defense in the 1970s to create a robust, fault-tolerant, and flexible network for communication. It predates the OSI Open System Interconnected model, which was proposed in the late 1970s by the International Organization for Standardization. As a more theoretical and generalized framework, they describe how different network protocols communicate. Because the TCP/IP suite was designed with a practical implementation in mind, its layers do not match the OSI model's layers exactly. Today, however, the TCP/IP model is often thought of as a four-layer model more closely aligned with the OSI model. These four layers are application layer, transport layer, internet layer, and network access layer. The OSI model and TCP/IP protocol suites are the two different networks for understanding and implementing network communication. Both have been influential in the development of modern networks, but they differ in structure, purpose, and practical application. The OSI model was designed as a theoretical framework to guide the development of standards and ensure vendor capability. The TCP/IP model was designed specifically for practical communication over the Internet, focusing on simplicity and a robust functionality. The OSA model is more comprehensive and theoretical, but it is not widely implemented in its full form. The TCP/IP model is the backbone of modern Internet communication and is widely used for real-world networking. The OSA model has seven layers, allowing more detailed separation of functions. For example, distinguishing between session and presentation layers. The TCP/IP model simplifies things with four layers, combining some of the OSA layers. For example, application, presentation, and session layers into application layer. And the first layer of the TCP/IP model is network interface layer. This layer handles communication on the local network segment and manage the physical and logical connection between these devices. Some of the responsibilities of network interface layers are data framing, encapsulates data into frames for transmitting over the network, physical addressing, use a MAC address to identify devices on the same local network, error detection and correction, detects and may correct errors in data frames during transmission. Media access control manages how multiple devices share the same physical medium. Some of the examples of network interface layers are Ethernet, Wi-Fi, point-to-point protocol. The Internet layer manages logical addressing and routing of data packets across multiple networks. The responsibilities of Internet layers are IP addressing, assign and manages IP addresses for devices, enabling data packets to be routed from source to destination. Determines the best path for data packets to travel through interconnected networks. Packet forwarding moves packets through routers and other network devices. Some of the key protocols used in Internet layers are IP Internet Protocol. It handles packet addressing and routing. It includes IP version 4 and IP version 6. Second one, Internet Control Message Protocol, used for error reporting and network diagnostics. For example, the command ping. IP version 4 and IP version 6 protocols for used for addressing and routing routers devices that forward packets between different networks. Transport layers provides end-to-end communication services and ensures reliable or fast data transmission between devices. Some of the responsibilities of transport layers are reliable data transfer. It ensures data is delivered accurately and in the correct order via transmission control protocol. Flow control, it manages the rate of data transmission to avoid congestion. Segmentation and reassembly breaks down the large data message into smaller packets and reassemble them at the destination. Some of the key protocols used in the transport layers are TCP and UDP. Transmission Control Protocol provides reliable connection-oriented communication with error recovery and flow control. User Datagram Protocol provides faster connectionless communication without guarantees of delivery. Application layer provides network services directly to the applications and manages the interface between application software and network protocols. The key responsibilities of applications layer are service offering. It supports various network applications and services such as web browsing, email, and file transfers. Data representation. It handles data formatting, encryption, and compression for compatibility and security. Session management manages sessions or connections between applications. Some of the key protocols used in the application layers are Hypertext Transfer Protocol, secure. It is used for web communication. SMTP, Simple Mail Transfer Protocol, used for sending mails. Post Office Protocol, Internet Message Access Protocol, used for receiving message. FTP File Transfer Protocol, used for transferring files. Domain Name System resolves domain names to IP addresses.